Saxon's Calculus Lesson 33 is about the derivative of x to the n and notations for the derivative, which we've basically talked about. I said there was a lesson coming where we learned a shortcut, and thankfully this is it. But to get there, they run you through remembering that your derivative has to do with your slope, the rise over run, and that rise is a change in y over a change in x. And when we do that, we get that formula, which was f of x plus the change in x minus f of x all over the change in x. And if, oh, they walk through, okay. So they do another example here of what happens if you plug in x cubed and you simplify that. Yes, okay. I was looking to see exactly when they gave you the shortcut. So what they do in example 1 is they say find the derivative of this original x to the n, not this x to the cubed. And they say where n is a counting number where you're plugging in a 1 and then a 2 and then a 3 and then a 4 and so on forever, what do you end up getting? So if you go through plugging in x to the n here, you have your x plus change in x to the nth power minus your x to the nth power over your change in x. And if you manipulate that all the way down, you get to this. And they change it to the format of d over dx, which you should recognize or start to recognize is a derivative of x to the n. And when you simplify that, what you get is n with x to the n minus 1. This is the beautiful formula to basically memorize. So if we have x to the n, what they're doing is they're taking the exponent, they're multiplying it in front, you keep the base x, and then you always subtract 1 from the exponent and you have it. So if I want to derive, bypassing the lovely formula which takes forever, x cubed, let's follow that. Pull the 3 out to the front, keep the x, subtract 1 off the exponent, 3 minus 1 is 2. That's what I get if I plug x cubed in and manipulate this fraction. I will always get down to 3x squared. So it's the beautiful shortcut. Now, they teach you the shortcut, then they don't actually ask you to use it at the moment. They change back to part B where they're using it, but they're titling it the notations for. So remember that another notation for derivative is when you're given y prime. So that means find the derivative of it. And in example 2, part A, they give you y equals x to the 4th. So let's do our shortcut. 4x cubed, derived and done. So much faster than that formula. And then in part B, x to the pi. So pi with x to pi minus 1, because I can't work that out, but it's beautifully solved. There's the derivative. Example 3. This time they give me f prime of x, again, find the derivative, and g prime of x, same thing, find the derivative. So in A, it says find the derivative of f of x equals x to the negative 7th. So negative 7 pulls down, x to the, and when I minus 1 more, I get negative 8 derived. Part B, g of x is 1 over x to the 15th. Now this one I do need to make a minor adjustment before I can follow the formula, and I need this to not be in a fraction, so I can write this as x, and if I put it up at the top I change its sign, so it's x to the negative 15th basically. Now follow the rule, negative 15x to the negative 16th, derived. Example 4. If the f equation is y equals x to the negative 2/5, find f prime. Again, find the derivative. So negative 2/5 x to the, and if I minus 1 from this, that's minusing 5/5, so that's negative 7/5 derived. Isn't the Lovely shortcut, just beautiful. I hate having to do that even for like a lesson because I know where you're headed. Example 5. If s of t is t to the 3/5, find the derivative. Sorry, I'm laughing because of the way that they wrote it. They're saying find s prime of t, which means find the derivative of that. And then it says, and s prime, same thing, derivative, and find ds over dt. That's the same derivatives. They basically just said derive the same thing 3 times. So you only have to do it once. You just need to recognize all of those are formats for derivatives. So when we do that, 3/5 comes to the front, and then it's t, and when we minus 1 from this, that's minusing 5/5. So that's negative 2/5 for the exponent. If I could turn the page, I would verify that that was the last example.